This is the first topic I've seen in our book. I was a little surprised. This is something I normally teach in a college algebra course, and I'm sure you see it in Algebra 2 in high school as well. We have to do division of a polynomial by a binomial, which is essentially it's going to be the exact same process as long division. So in order to understand this, what you've got to remember is how to do something like this. Hold on, let me see if they're going to jumping ahead here. Okay. I don't know if we'll have remainders. That's what I was trying to see. But so if you don't remember this, it may have been a while, I totally understand. But the process for what we're going to do is exactly the same as this. I'm trying to divide 4 into 2. Well, it doesn't go. So I'm going to go 4 into 21 goes 5 times. I'm dividing 4 into 21 the best I can, and the answer is 5. Now, 5 times 4 is 20, and what I call it, let's check for leftovers. I had 1 left over. Now, bring the 9 down to join them. Now I've got 19 there. Let's go 4 into 19 the best we can. It would be 4. 4 times 4 is 16. Check for leftovers. I have 3. We'd call that a remainder 3. Now, I have a feeling we won't see remainders in this. But here's the exact same process. So I am dividing this. Now we could write it as a fraction bar, but that's not going to help us here because of the plus, it's going to make things very complicated. So what we have to do is go old school long division. So the difference between this section and the last one is now this is a binomial. The plus has made this all one giant number, and we can't just do the trick we did in the last video. So we're going to do long division, and they've started it for us here. So I'm going to turn this, it's the first one into there. So I don't need to worry about the 5 yet. What I'm going to do is just how do I turn x into x squared? Well, do you see x would be the way to do that? Now, what I'm going to do next is just like I did up here. 5 times 4 is 20. Well, I'm going to do x, but it's times x plus 5. So really, this is what I'm doing next. So up here, 5 times 4 is 20. Well, now I'm doing x times x plus 5 is, and now this is the distributive property. There times there times there. So it's x squared plus 5x. Okay, now it's difficult to show that every time, but so it's x times both of these. You could think of it as x times x is x squared, x times 5 is 5x. Now, up here we check for leftovers. We're going to do it here. We're going to subtract. This is the other twist that makes it more difficult with binomials here. It was easy to know. I'm subtracting 20, there's 1 left over. If I'm subtracting this binomial, it changes the sign of both of them. So what I'm doing is x squared plus 9x minus x squared minus 5x. Now it's also difficult to show this, especially without a pencil, but I recommend some students just go ahead and change all the signs through there. There's not a real great way to do it. I do this, and in my mind, I remember that they need to change signs. But this is an easy place to make a mistake. So do this any way you want. Either write it like this, or know that you've gone through and changed the individual signs with your pencil. Whatever you want to do. But don't lose the fact that you have to change signs, or you're going to mess this up. That's a common place it gets messed up. Okay, so now I'm subtracting these. The x squareds would now be gone. I have 9x minus 5x. I would have I'd have positive 4x. So over here, 9x, it's minus 5x. Okay, now I bring down my number. So these should always disappear. If you did this right, this first term should always go, or you didn't choose the right number. Now bring down a 20, and just like up here, I brought down the 9. Now I'm going to play the game again. 4 into 19. What could I do to make that happen? Well, I'm going to turn x into 4x. Just the front. That's all you have to check. It'll take care of itself. So x into 4x would be if I multiplied by a positive 4. So, and it's a new term, so I need to show that it's a plus 4. Now let's multiply. 4 times x is 4x. 4 times 5 is 20. Now we check for leftovers, which means changing both of their signs. And if I do that, it's going to make everything disappear and there's no remainder. So if I divide all of this, all the way back here, if I divide this by x plus 5, what I get as an answer is x plus 4. Okay, let's try another one of these. I'm sure you need to see this. This is weird. So here's what I'm doing. I'm going to put this in the house. Now, all I have to do is turn y into y squared. And the way I would do that is just by multiplying by y. Now, y times y is y squared. Y times 3 is plus 3. Y plus 3y. Now, I'm going to show it like this, but it means we're changing all the signs. So the y squareds are going to go. This is now negative 3y. So 10y minus 3y is 7y. Okay, let's bring down the next term, just like we would have done in middle school, elementary school, wherever you learned that. Now let's get the front ends to match. Y times 7y, it would be a 7. That would make that a match. So 7 times y is 7y. 7 times 3 is 21. Now, we check for leftovers. It becomes subtraction. Now it changes every one of the signs. There's no remainder. So my answer, when you divide these, is y plus 7. Okay, you probably know what I'm going to say. I recommend you pause the video. Alright, so I'm dividing these two guys. I need m to turn into m squared. Just need to worry about the front end. So I'm going to do m. M times m is m squared. M times 4 is 4m. Check for my leftovers. This is not a 4m anymore. It's a minus 4m. So 9 minus 4m gets me 5m. Bring down my next number. Let's make m turn into 5m. Okay, we could do that by multiplying by 5. So 5 times m is 5m. 5 times 4 is 20. Okay, check for leftovers here. And so it would change all the signs. There would be nothing, no remainder. So m plus 5 is our answer. Okay, yeah, I don't know. Hold on, I'm going to jump to the end of this. I don't know if there's anything different. So let's pick it up here. We'll talk through theirs. They're looking to turn x into 2x squared. Yeah, that's all they're doing. It's a little bit different. To turn x into 2x squared, I would need 2x. 2x times x, multiply through. So, and instead of me, it's the exact same process. Let me just do one. Let's stop looking at theirs because it's hard to walk through that. So all they did was, instead of it being an x squared in the front, there's a coefficient in front of there. So it's the same game. How do I turn x into 2x squared? Well, that would be 2x. So 2x times x is 2x squared. 2x times negative 4 is negative 8x. Now we check for leftovers. This is not negative 8x anymore. It's positive 8x. So I'd have 5x left over. Bring down the negative 20. Okay, x into 5x. We need a 5 to make that happen. So 5 times x is 5x. 5 times negative 4 is negative 20. Okay, the first one, if you did it right, the first one should always go away. This is not negative 20 anymore, it's positive 20, so there's no remainder. Okay, how do I turn x? Just the front one. How do I turn x into 3x squared? I would do that by 3x. So 3x times x is 3x squared. 3x and negative 6 is negative 18x. Check for leftovers. Okay, this isn't negative 18, it's positive 18 now, so 2x. Bring down the next number. X into 2x, it's going to take a positive 2 to do that. So 2 times x, 2 times negative 6, so no leftovers. So I don't know if there's never going to be any remainders here. I'm not sure. In college algebra, we'd have remainders. We would deal with that. So maybe that's coming. I'm not sure. Nothing has changed here. We just have an extra term. All we have to do now is we've got this is a polynomial with 4 terms, but the process is the same. So I'm going to jump through what they're doing here, and we're just going to work one. Nothing changes except it's going to take one more round of division. So let me show you. Okay, so we've got more terms to go into, but nothing changes. How do I turn x into x to the third? Well, I need x to the second. Now x to the second times x. So I'm doing the same thing, checking for leftovers. This isn't 2x anymore, it's negative 2x. Gives me 3x squared. I'm going to bring down the 8x. All right, how does x turn into 3x squared? It would be positive 3x. Now 3x times each of those, 3x squared plus 6x. Check for leftovers. This is negative 6, so this gets me 2x. Okay, how do I turn x into 2x? It would be plus 2. So 2x plus, oh, did I get a leftover? 2x squared. I did. Was I supposed to? Okay, so if I'd have a remainder of 2. Let me go back. I don't know. Yeah, they did do that. Okay, so what's different here? This is actually true in basic math as well. Like, I don't think I want to show all this, but when we, well, what the heck? When we have, oh no, that's not going to work. I need this. This is an improper fraction, and we could turn this into a mixed number. And when we did that, what we would do is we divided 2 into 11, and we get 5. But there's 1 as a remainder, so we could make this 5 over 1/2. Do you remember doing this? So as a mixed number, this is 5.5. Well, when we have a remainder, we're really doing exactly the same thing. I'm putting that 1 over what we divided by, which is what we did right here. So it's the same concept. I put the 1 over what we divided by, and I get 5 and 1/2. Well, here I have a remainder of 2. So we actually don't do it in higher math as like R2. What we would do is I would just say, okay, I would add on that remainder of 2, but it wasn't just a whole 2, it was 2 over x plus 2. Okay, let me do another one of these. If you think you got it, go ahead, try it on your own. But I wasn't expecting the remainder, so let's talk through that again. Okay, x into 2x to the third. It's going to take 2x squared to make that work. Now we check for leftovers. This is negative 2x squared now, so I'd have 6x squared plus x. Okay, x into 6x squared. So 6x is what it's going to take to make that happen. 6x times all of this gets me 6x squared plus 6x. So 6x times x, 6x times 1. Now, check for leftovers. The front end is gone. This is now negative 6x, so it's negative 5x when you put them together. 1 there, minus 5, or minus 6 there. Bring down my negative 8. We got one more turn. X into negative 5x is negative 5. So I multiply this, negative 5 times x, negative 5x. Negative 5 times 1 is negative 5. So check for leftovers. Now this is a positive 5, so I'm going to have a remainder of negative 3. So what I would do, I would put the negative sign out front because it's going to be a fraction and you're allowed to do that. You put the 3, the remainder, over the x plus 1. So the negative is gone there. So remember last time I did a plus out there? Well, it was because it was a positive number. So a negative number, I'm going to put a negative out there, and it's 3 over x plus 1. Wow, they're doing a lot more here than I thought. I'm not going to take, I'll do the next one and not going to show all theirs, but you need placeholders here. So it needs to go descend all the way down from every degree. Do you see that we have x to the fourth, but we don't have any x to the thirds? we're missing that. And if we skip that, it'll mess up the process. It won't work out right. So I'm going to add in a placeholder to say, hey, wait a minute, we can't forget about the x to the third place or this is going to mess up. So as long as you catch that, and that's an easy thing to miss, as long as you catch that, the process is the same thing. Okay, now I know I just jumped through theirs, but let's do one here. The issue here is there's no x to the second. There are none of those. And if we skip that, it will mess up how we divide. So I'm going to add 0x to the seconds. We have to have that just as a placeholder or else the process goes askew. Okay, so I'm going to turn, now it becomes the same thing. As long as you caught that, we're going to do the same game. X into x to the third is x to the second. This is x to the third plus 2x squared. So I'm doing the same thing, x times each of those. Now, check for remainders. This is negative 2x squared now. So 0 and negative 2x squared, negative 2x squared. Bring down the next one. How do I turn x into negative 2x squared? Well, I would be negative 2x. Okay, negative 2x multiplied through here. Do my remainders. This is plus 4x, so I have 7x. Bring down my 14. X into 7x is plus 7. So then the same thing. Oh, no remainder this time. 7x plus 14. There's no remainder. Okay, this one needs a placeholder. Be great if you tried this. Zero x to the second. Oh, it needs two placeholders. There's also no x's. So if you tried it on your own, I hope you caught that. Okay, let's get going here. So x into x to the fourth, it would take x to the third. Okay, I'm not going to talk through all the steps anymore. Same thing, hope you get this. If not, go back to the beginning of this lesson. Okay, so negative 5x squared, so I got negative 8x to the third. Oh, you know what? You might have had a hard time with this if you try this on your own. So if I bring down the 0x squared, well, hold on. Let me see if it will work this way. Hold on. Okay, so x into negative 8x to the third would be negative 8x squared. That's what I would need to make this work. Yeah, no, I think you do need to do that. I was jumping ahead. I was thinking of something else. I think this is fine to keep doing this way. So negative 8x squared, we multiply that through, we get this. Okay, check for my leftovers. So this is actually positive 40x squared. So there were 0x squareds and now positive 40x squared, I get this. Okay, let's bring down our 0x's. Okay, x into 40x squared, that would be 40x. So I've got 40x squared plus 200x. Leftovers, I'm going to have negative 200x minus 1000. These numbers have gotten a little odd. Okay, so let's get this to match up. X into this is negative 200 to get the front terms to match. Now, negative 200, so you get this. Negative 200 times 5 is negative 1000. Change our signs. And this is a plus, so everything's gone. So I get all of that madness. Okay, I'm going to just step through there. Oh, that's nice. Yeah, I'm just looking for something different and I don't see it. So it just needed the two placeholders. We've already seen that. So let me just work this. So x to the third, 0x to the second, plus 0x minus 64. Okay, process is the same. So x into x to the third, x squared. Leftover time. So that's a positive, so it's 4x squared plus 0 x's. X into 4x squared, I need a positive 4x. Okay, doing it by both of them. This is not negative 16x, it's positive 16x. If you add that to 0, nothing, it's just 16x. Okay, x into 16x, it takes 16 to make that work. Now this times both of them, 16x minus 64. Okay, you get no remainder. Yeah, sorry, just checking to see what else, if anything. So pause it if you want to try this one. I'm going to go ahead and start. Zero x squareds. 0x because I need all those placeholders. Okay, 5 into 125. 25 times, so 25x to the second. This is minus 50x squared. Okay, negatives run through. This is now 50x to the second. Bring down our placeholder. 5x into 50x squared. That would be 10x that we would need. So change the signs. This is 20x minus 8. Okay, 5x into 20x, that would be 4 that would do that. 4 times negative 2 is negative 8. Check for leftovers, you get a 0. Okay, so no remainder, and that would be our answer. All right, a little surprised by that topic. It's a little challenging, but as long as you remember, it follows all of the same process of just long division that you did when you were a kid. And follow that same process, and you'll be fine.